Alright then, let us continue from question number 21. The question says, a few drops of concentrated hydrochloric acid are added to about 10 centimeter cube of a solution of pH 3.4. The pH of the resulting mixture is A less than 3.4, B greater than 3.4, C unaltered, D the same as that of the pure water. Now let's look at a chart on pH scale that will give us a better information as to how to go about this question. Now, according to the pH scale, if you are adding an acid, okay, the pH decreases because acid has a lower pH compared to base. For base, if you are increasing the concentration of a base, the pH increases. So of course, if I have a pH of 3.4 and I add an acid, the pH will be less than 3.4. So the correct answer is option A. All right, next question. The next question says, chromatography is used to separate components of mixture which differ in their rates of A, diffusion, B, migration, C, reaction, and of course D, sedimentation. But let's look at the definition of chromatography so that we'll be able to answer this question. Chromatography is a separation technique used to separate the components of mixtures based on their differential rates of migration through a stationary phase. Now, from this definition, our correct answer must be B, via their differential rates of migration. Next question says, deliquescent substances are also option A, efflorescent, option B, anhydrous, option C, hygroscopic, option D, insoluble. But let's look at the definition of the following key terms: deliquescent, efflorescent, and hygroscopic substances. Now, deliquescent substances form an aqueous solution by absorbing water vapor. That is when they are exposed to air. Efflorescent substances do not form a solution. They lose their water of crystallization. A very good example is hydrated copper 2 sulfate. Isn't it? Upon exposure to air, it loses its water of crystallization. Now, hygroscopic substances, on the other hand, are substances that do not form a solution but absorb water vapor. Therefore, we can say deliquescent substances are also hygroscopic. So the correct option is C. All right, then, the next question says, helium is used in observation of balloons because it is A, light and combustible, B, light and non-combustible, C, heavy and combustible, and then D, heavy and non-combustible. But let us have one or two informations about helium that will give us the ability to answer this question. Now, helium is used in filling balloons for observation because it is less dense than air, which allows the balloon to float. This property of helium makes it buoyant, and when a balloon is filled with helium gas, it becomes lighter than the surrounding air, causing the balloon to rise. As such, it is a safer and more practical gas for filling balloons for this purpose compared to other gases, such as hydrogen, which is flammable and presents safety risks. So the correct answer must be option B. All right, then, the next question. The next question says, 32 grams of anhydrous copper 2 tetraoxosulfate 6 dissolved in 1 dm cube of water generated 13 kilojoules of heat. The heat solution is option A, 26 kilojoules per mole. Option B, 65 kilojoules per mole. Option C, 130 kilojoules per mole. And of course, option D, 260 kilojoules per mole. Now, without giving the formula, we need to look at this. I have 13 kilojoules, and the options I have are all in kilojoules per mole. So I know that I need to divide the quantity of heat given over the mole of the anhydrous copper 2 sulfate. But how do I do that? Let's look at this, please. Now, heat solution, the formula for heat solution is given by quantity of heat over mole. We were given the quantity of heat to be 13 kilojoules. The mass of anhydrous copper 2 sulfate given was 32 grams. And of course, evaluating the molar mass of copper 2 sulfate, copper is 64, sulfur is 32, oxygen is 16 times 4. Upon calculation, I'm going to have 160 grams per mole. Now, evaluating this, you need to remember that number of mole is mass over molar mass. So the given mass, which is 32 grams, over the molar mass, which is 160, will give us 0.2 mole, isn't it? By extension, H will be equals to 13, which is the value of Q, over the mole, we got 0.2. And we are going to have 65 kilojoules per mole. All right, then, the next question says, a gaseous metallic chloride consists of 20.22% of M by mass. The formula of the chloride is, we were given the atomic mass of M to be 27, the atomic mass of chlorine to be 35.5. Option A says, the formula becomes MCl. Option B, MCl2. Option C, MCl3. And then option D, M2Cl6. But how do we solve this, please? All right, let's have a look at this table, please. Now, we were given percentage composition, M 20.22, chlorine 79.78. The atomic mass were 27 and 35.5 respectively. The first thing to do is you need to take or get your mole ratio. But how do you do that? The given percentage composition will be divided by the atomic mass in each case. So if I divide 20.22 over 27, I will have 0.75. If I divide 79.78 over 35.5, I will have 2.25. The next step must be you divide by the smallest mole. And of course, the smallest here is 0.75. Okay? So 0.75 divided by 0.75, I will have 1. 2.25 divided by 0.75, I will have 3. Obviously, my empirical formula will be MCl3. So the correct answer is option C. All right, then, the next question says, what quantity of electricity will liberate 0.125 mole of oxygen molecules during the electrolysis of dilute sodium chloride solution? The options provided include A, 24,125 coulombs, B, 48,250 coulombs, C, 72,375 coulombs, and then D, 96,500 coulombs. How do we solve this, please? All right, let's have a look. You need to remember the equation of reaction that happens at the anode and at the cathode during electrolysis of dilute sodium chloride, isn't it? Now, at the anode, okay, we have OH minus giving oxygen gas, but the balance equation is like this. 4 moles of OH minus giving O2 plus 2 molecules of water. And of course, it is oxidation, electrons will be lost, isn't it? Now, this means that 1 mole of oxygen gives 4 moles of Faraday or 4 moles of electron from our equation, isn't it? But you must remember that 1 electron has a value of 96,500 coulombs, isn't it? So now, 0.125 mole of oxygen given in the question will give us how many coulombs? We don't know. So we call it X. By simple cross multiplication, X will be equals to 0.125 times 4 times 96,500, isn't it? And of course, our answer will be 48,250 coulombs. Pretty easy, isn't it? Now, the next question says, which of the following types of bonding does not involve the formation of new substances? A, metallic bonding. B, covalent bonding. C, coordinate bonding. And then lastly, electrovalent bonding. Now, very quickly, covalent bonding is a type of bonding that involves sharing of electrons, isn't it? And of course, in covalent bonding, new substances are formed. Coordinate bonding is a type of bonding that also involves sharing of electrons. However, the electrons being shared are contributed by only one of the participating atoms, isn't it? And then in electrovalent bonding, it involves transfer of electrons from a metal to a non-metal, isn't it? All right, then, what about metallic bonding? Now, metallic bonding, atoms within a metal structure share their outermost electrons in a sea of delocalized electrons. However, this bonding doesn't result in the creation of entirely new chemical compounds, isn't it? So our correct answer must be option A. Now, the next question. The next question says, an organic compound that does not undergo a reaction with both hydrogen cyanide and hydroxylamine can be option A, alkene, option B, alkanal, option C, alkanone, option D, alkanoic acid. Now let's quickly look at the reactions of the following functional groups. Now, if you treat an aldehyde, okay, or an alkanal with hydrogen cyanide, you are going to have this compound. Are we together? You are going to have hydroxynitride. Okay? Similarly, if you treat acetone or ketones, okay, with hydrogen cyanide, you are going to have hydroxynitride. So that means they react, isn't it? If you treat them with hydroxylamine, you are going to have acetaldehyde oxime or acetone oxime, isn't it? That means they react, so they cannot be the answer, isn't it? All right then. What about alkanoic acid? Similarly, alkanoic acid undergoes reaction with both hydroxylamine, are we together, in this case forming an amide, and with HCN. So the correct answer must be alkenes. Alkenes typically do not undergo reactions with hydrogen cyanide or hydroxylamine. They lack the functional groups necessary for this specific reaction. So the correct option is option A. The next question says, the substance often used for vulcanization of rubber is A, chlorine, B, hydrogen peroxide, C, sulfur, and then D, tetraoxosulfate 6 acid. Now let's look at this, please. The substance commonly used for vulcanization of rubber is sulfur. What is vulcanization, please? Vulcanization is a chemical process in which natural or synthetic rubber is treated with sulfur and other additives under heat and pressure. This process cross-links the polymer chains in rubber, improving one, its strength, elasticity, and durability. It also makes the rubber more resistant to heat and deformation, isn't it? So the correct answer must be option C.